Hey, hope you had a great Memorial Day weekend. Crazy weather. Hot and humid, definitely summery feeling out there. This week we're going to talk about like types of things that affect weather in the short term and actually affect climate. And we want to start thinking about climate a little bit. We're going to talk about the El Nino Southern Oscillation, otherwise known as ENSO. The big key to it is looking at where the hot water in the equatorial Pacific sets itself up. It can be set up as being really hot over towards South America. It can be set up being really hot in the Central Pacific. And what we want to do is look at that and remember that what happens down there affects us up here in Wisconsin. So the El Nino Southern Oscillation is basically a disruption. It's actually an oscillation. It's a big convection cell that occurs in the ocean, and it can vary at times. And the big characteristic is that surface temperature in the equatorial Pacific is mobile, doesn't stay in one spot, and it greatly affects our weather. And we actually have the world's largest scientific instrument to measure it, and it's predictable. Scientists understand enough about it that they can predict it. And we'll talk a little bit about that. This is where that occurs. This is the equatorial Pacific, yet this large ocean, and where the hot water here has a lot of effect on weather because of evaporation. The evaporation from the ocean can transfer heat and moisture to the atmosphere. So if it's really hot towards one side or the other, you're going to get more evaporation, and that can change things. And the big thing that seems to change during an El Nino is what we call an upwelling. An upwelling is if the warm water moves on if the warm water moves to one side of the Pacific Ocean basin, um, as it moves, the cold water has to come up to replace the warm water that's moved. That cold water is usually nutrient rich and it's really good for fishing. And that's where we first noticed this. This was off the coast of Peru, and why we have that Spanish name, El Nino, because when the waters were really warm off that ocean, a lot less people were able to catch fish because there wasn't any upwelling there. ENSO is an example of a periodic interaction between the ocean and the atmosphere, and it greatly influences global weather. So let's talk about what happens under normal conditions. Here is South America, here's Australia, and typically normal conditions have the warm water located over towards Australia and an upwelling off the coast of South America near Peru. Basically, that leads to strong trade winds. As the winds blow this way, they push all that warm water over there. And these push it basically to the coast of New Guinea and Australia. The cool water upwells and it moves in to replace that water, and that makes the fishing great, but it affects the weather on the land in all these areas. And heavy rains typically then are concentrated over the warmest water. That's where you get the most evaporation. And so Australia gets plenty of water, and the tropical effects of everything and all that rainfall is there normally. During El Nino, notice what happens in El Nino. Notice that number one, the trade winds are weakening. The warm water isn't being pushed over to Australia, it's kind of being spread out all over the Pacific, and actually will start to migrate towards South America. That weakening trade wind then basically moves that water towards the Americas. And what we see is the upwelling starts to decrease. Fishermen can't catch their fish. And the warm water comes over here and causes a lot more rain and flooding on this side. And guess what? If the water leaves there, it causes a lot more drought because there's not as much evaporation. Um, this also then, because of these storms forming here, alters the jet stream, and that's why it can affect us even in Wisconsin, because it can push those jet streams in slightly different areas. So during an El Nino or its cousin La Nina, this is the warm water off. This is cold water off warm water off the coast of Peru, and this is very cold water off the coast of Peru, you can get a lot more destructive rain events. Things tend to be, I don't know, we get a lot more droughts and bushfires. Hurricanes in certain areas can be increasing. Tropical storms can increase. Definitely coastal flooding is affected. And of course, the fishing is dramatically affected. So if we look here during December through February, during an El Nino year, where the warm water is over here, not over here, notice it dries out and it's really dry, but it also affects Africa. And for us, we see not much of an effect, but warmer winters seem to come up around this part of time. And of course, it even affects South America and other parts. There's a lot of effects based on this moving warm water in the equatorial Pacific. How is it predictable? Well, remember, under normal conditions, the warm water is over towards Australia, and under El Nino conditions, the warm water is over towards South America. How do they find out about this? Well, it's predicted by looking at sea surface anomalies, SST, sea surface anomalies. Basically, it looks at the upper millimeters, and they can use this with satellites or with the instruments that they have out there. At the upper millimeter, what's the temperature? And an anomaly is if it was normally supposed to be 15 degrees centigrade, but it's 18 degrees centigrade, that's a 3-degree anomaly. So they look at anomalies, and they look at something called the Southern Oscillation Index, which actually looks at atmospheric pressure in a couple of locations in the South Pacific. And they combine those things, and they understand that there's a seesaw of air pressure systems between the Western and Eastern Pacific, and that's what they call and basically help predict what's going to happen and when El Nino will form. Right here is that Southern Oscillation Index. It's that large scale air pressure differences that can occur between two spots, Tahiti in the South and Darwin, Australia. And what do we see? We see that when we get these peaks where the pressure differences are really low, that's when we get El Ninos that lead to the tropical effects or the effects of El Nino. Here would then be La Ninas. And we can look at it this way, but most people just look at the temperatures. When you look at the temperatures, the color codes here are basically the relatively warm is red and the relatively cool is blue. And this is pretty normal. If Australia is here and South America is here, notice that it's blue over towards South America, red towards Australia. That is going to be normal. El Nino occurs when that warm air or that warm water is all over the place and there's no upwelling. And that leads to changes. La Nina is the sister of this, and basically it's just the opposite effects. It's usually unusually cold weather in the eastern equatorial Pacific versus unusually warm water there. And the trade winds increase and upwelling goes up, and it affects definitely all of the weather around the Pacific Ocean basin. Look at these three images of sea surface temperatures, right? And if we look at these in 98, 93, and 97, can you look at this and tell me when was it a normal year? When was it an El Nino year? And when was it a La Nina year? Make sure you understand La Nina, excessive cold water upwelling around the eastern Pacific. Normal is a little bit of upwelling and obviously the warm weather there. And El Nino means relatively warm water all across the Pacific. These things affect us all. I mean, for instance, during an El Nino year or a La Nina year, the jet stream moves. It gets pushed because there's all this evaporation occurring down here. It pushes that up and around. And during an El Nino year, in Wisconsin, for instance, the jet stream, the polar jet stream, has moved north. And so that means we don't get as cold a winter. And because of that, we usually get less snow because whatever precipitation we get falls as rain. So, what I would love for you to do is understand that you guys should understand, learn a little bit about this climatic system, this little longer term. Usually we think about weather in just short terms. And so, what I would love for you to do is read this little textbook and watch this little useful video. That'll also help you about this as you go through and answer your questions. Remember, you can write a short answer or take this quiz to show your understanding. And you guys, thank you for your time. This is one of the last topics we got. We're getting near the end of the year. Stay healthy.